Now in this question I think I will use the cos diagram again, this time to solve cos 2x equals minus 0.8 between 0 and 180 degrees. I've crossed out part A because it's very similar to the previous example I did. In the previous example I also forgot how to show you how to use the graph method, but I'll do that here, and you can see that that's probably the simplest method. So to start off this question, I would write cos 2x equals minus 0.8, 0 to 180, and deal with the range first of all. So remember, you treat this as a block. Keep that 2x together until right at the very end of the question, only at the very end where you divide everything by 2. So if x is between 0 and 180, 2x will be between 360 and 0. Okay, so you doubled x, so you double 180 and you double 0. So this is the new range where we have to find all our values for in the cos diagram. So do what you normally do next. You do the inverse of cos of minus 0.8 on your calculator. That will give you the principal value, which is what is that, 143.1, I think, 143.1. So that's our principal value. Now, as I said before, whatever you do, don't divide by 2 now. You need to use the cos diagram next. So remember, the cos diagram is just says where everything is positive. Okay, now if we look at our question, you can see that the question is negative here. So we want to find all the regions where cos is negative. So cos is positive here and here. So the regions where cos is negative are here and here. Okay, now our calculator's given us one value, which was 143. So 0, 90, 180, 270, 360. So 143.1 is going to be over between 90 and 180. So let's just draw it over here. So that angle there is 143.1 degrees. Now we've already circled this down here, so that's where we want the other line to be. So you reflect it, and then this angle here will also be 143.1 degrees. So now you just start on 0 all the time and find as many values as you need in your range. So every time you hit one of these lines, you just write down a value. 143.1, already got that one. So let's do another one all the way around. Bang, hit the line. That will be 360 minus 143.1, which I think is 216. I'll write it over here, 216.9. And we can carry on going if we like. We can carry on going all the way around until we hit the line again, but that would be way beyond 360. Okay, we need the range to be between 0 and 360. So we don't want any more values. Those are the two values we have in our range. Now, what I forgot to show you in the previous video was how you could use the graph to do this. This is the easiest method, I think, for solving these. You just get the graph of cos x. Remember, this is cos x. Whoops. It's not the graph of cos 2x, but that's fine. So if we draw our line at minus 0.8, see if I can get the line at minus 0.8 down here. I think that's good enough. So you draw your line at minus 0.8 because that's what you're solving cos equal to, and then your calculator gave you this value here. So this value here was 143.1, and you can, so that there's that solution there. You're just finding all the places where the red curve of cos x meets the blue line, and the blue line is y equals minus 0.8. So where does cos x meet y minus 0.8? Well, 143.1, we got that from the calculator. There's another value here, so we need to decide what that value is there. Then there's lots of ways of doing this. You could say that this distance is the same as this distance. It's symmetrical, isn't it? So you could do 360 minus 143.1, or you could do it like this. You could say this distance here is the same as this distance. Okay, so you can work out the two green distances and then find what this point here is. However you do it, I did it by doing 360 minus 143.1, and that gave me this value of 216.9. If we wanted negative values, which we don't in this question, but there would be one over here, there would be one over here, and again these green distances would be the same. I'm not drawing this particularly well, but that distance would be the same as that distance and that distance, so all these green distances would be the same. So anyway, I think if you're struggling with the cast diagram and you don't like general solutions, then you can always use the graphs. You need to know the graphs of sine, cos and tan anyway. Often you're asked to sketch transformations of trig functions, so you can always use the graphs. It's just that it takes a bit longer if you've not already got the graph drawn in the previous part of the question. So anyway, however you find these two values, you should get these two, and then right at the very end you now divide by 2 and divide by 2. So our answers are x equals 71.6 degrees and what's the other one, 108.4 degrees. So those are the two final answers. So as I said before, you only divide by 2 at the very end of the question. Okay, let's just do one more example of using the cast diagram to solve trig equations. So this question here, it's exercise 10F question 1d in the textbook, between 0 and 360. Now straight away you might recognize that this looks a lot like a quadratic in disguise, and it is. If you were to let x equal tan theta, it would be even familiar as a quadratic, because you would get this. You don't have to do that substitution, letting x equal tan theta, but I'm going to do it because it helps to understand that this is no different from solving a quadratic equation, really. Certainly the first bit anyway. Also should explain that the range doesn't need changing for this question, because this is already theta over here. This is just theta and this is theta, so we don't need to change the range. It's not 2 theta or theta plus or minus anything. So that is fine, the range we have here between 0 and 360. So now we could just solve this quadratic. You might be able to factor, actually I don't think you can factorize this, but you can just use the equation solver on your calculator. Equation solver on calculator. You don't need to write that down, you can just write down the answers, which are, your calculator should give you these in third form: 1 plus root 11 and 1 minus root 11. Okay, so you just solve the quadratic on your calculator, you've got those two answers. Now we need to remember that actually x is tan theta, So we've got tan theta equals 1 plus root 11, and we've also got tan theta equals 1 minus root 11, and you just solve these two separately now, okay, as if they were two separate questions. The first one, 1 plus root 11, if we do this in our calculators, if we do inverse tan on your calculator, you're going to get, let me just check, you're going to get 77, whoops, I'm putting this in the wrong place, sorry. You're going to get 77.0 here, 77.0 degrees. Now, for tan is by far the easiest of the three trig functions to find alternative values for, because the tan graph just repeats every 180 degrees. To find the other values, you don't need to use the cast diagram or general solutions really. You just add 180s or subtract 180s as much as you want. We want values between 0 and 360, as it says in the question. So there's no point subtracting 180, that would be negative. So all I would do now is just add 180s to this. Okay, so plus 180 is going to give us, what would that be? That'd be 257. 257. We want three significant figures, by the way, so 257 will do. We don't need to write 0.0. If we add another 180, we're going to get 437. Whoops, but obviously that's not in our range, so we can forget about that. So tan is easy. You just you keep adding and subtracting 180s as much as you like, and until you go outside the range. You might be wondering, well, what if we did use the cast diagram? What would that look like? It would still work. It's just you don't need to use it. So I'll do it over here. SATC. We would have 77 degrees over here. Where is tan positive? Because this here is positive. Tan would be positive here, and tan would be positive here. So you would draw a line down here. This would also be 77 degrees. And so you would find all your angles the way you normally do. We would get 77. This would give us 257, and so on. So you can see why you just keep adding 180s. This should just be a straight line, really. Okay, so that's why you keep adding 180s. And if you look at, we're not finished yet because we now need to solve this. We haven't solved the equation on this side yet, so we need to do that now. By the way, this, if you type this into your calculator, you probably realize it yourself, but this will be negative. But again, you don't really need to draw the cast diagram. You just keep adding and subtracting 180s. So let's do inverse tan of this on our calculator. Theta equals tan to the minus 1 of 1 minus root 11. That's going to give us minus 66.7. And if we keep adding 180s, so keep adding 180s to this, plus 180, we're going to get 113 degrees. Remember, this is three significant figures. If we add 180 again, will this be in our range? Well, yes, it will, because that will be 293 degrees. If we add 180 again, that will be outside our range. So we can just leave it like that. And so our final values to this question will be the ones underlined in green here. So these are the four solutions. This one isn't in the range, so we will just get these answers.